Well, hello again. Today I want to talk about an old project of mine, and I'm talking about a desulphater. Desulphater, it's useful when the batteries develop and build up sulfate on the lead plates, particularly if the battery is allowed to become discharged. The build-up of sulfate prevents good contact with the electrolyte and therefore reduces the performances on the battery. So the desulphator applies short and powerful high-energy pulses to the battery at high frequencies, 1.2 kHz, and causing resonances of the plates and conversion of the sulfate back in the solution. The power to operate the desulphator is taken from an external power supply, in my case, and what I can say about, here we have a little oscilloscope, and we can see the frequencies and the volts and how the peaks are looking like. Okay. And there we go. You see the peaks are there, and now the frequency it's 183 Hertz. It's supposed to be at least 10 times higher, but I used for a while different frequencies, and this was the last experiment I did. All I can say about the spikes are, let's say, around 14 volts RMS, and I don't know what should I say about. I've been using that for 3 months, like I said, with different frequencies for weeks, and the car battery I experimented doesn't really get any kind of better behavior. So I don't know what to say, but it's looking like it's just a myth. Or maybe it's working for a battery that is just a little bit sulfated in the beginning of the process, but you'll never know when the process is. When you have a car battery or you have a lead acid solar battery or stuff like this, nobody's usually measuring every day to see how the battery behaves. So you finally are in the moment when you see that the battery is not working as it should, and in most of the cases it's too late to apply any kind of treatment. At least for me, I may say that this desulphator is just a myth. So that's how I did the board. It's very simple, and it's a 555 oscillator. It's easy to be done, and you'll have the schematic at the end of the video. And like I said, I'm using external power supply. Most of the desulphators are using the battery power to have these spikes, but I think it's better to have an external power supply. Then it can not only rejuvenate the battery but also keeping it charged all the time at a certain level. I think that's it for now. I said it's not by the way I did it, it's the conclusion and the results of a few months of testing this experiment on the batteries. Okay, so let's talk a little bit about the schematic. First of all, I have a power supply with 7812 that gives 12 volts, 1 amp that supply the desulphator, and then I have the desulphator itself. So this is a IC. This is a 555 IC and is configured like a standard PWM control mode, pulse wide modulation. And the output of the IC, it's amplified through a couple of transistors, so it's able to deliver the said high current pulses to the battery, which needs to be desulfated. The PMV control may be set to low mark ratio for implementing a desulfation process. The circuit is intended to be used for charging normal batteries. The control of the PNB will solely depend on the individual personal preferences. So, like I said before, I use different frequencies, but no results. So it should be done correctly by the battery manufacturer instruction, and that's hard to say about that. The 555 gives an oscillation. It can be adjusted by the 5 kilo ohms potentiometer, and that's how the pulses, how wide are the pulses in fact. And it's opening the MOSFET, and the MOSFET it's applying 15 volts, or in my case 12 volts, to the battery in spikes. That's the concept of the thing. Like I said before, doesn't really give me any results. So maybe I didn't use the right frequencies or the right voltage or something. But at least for now, for me, it's just a myth. But it's very clear for me when a lead acid battery is gone, it can't be fixed anyway. Changing the acid or using desulphater. When it's gone, it's gone. So thank you for now. I'll be happy to answer any question. Please comment and subscribe.